A mathematical proof technique used to establish a given statement or conjecture for all natural numbers. So the first step is finding the term. The formula is a sub n equals to a sub 1 plus n minus 1 times d. A sub 1 is our first term, which is 1, and d is our difference, which is also 1. So now we substitute. A sub n is equal to 1 plus n minus 1 times 1. And this becomes a sub n equal to 1 plus n minus 1. And now you get a sub n equals n. A series can be written in two ways, as a list of numbers and as a sigma notation. After we find the term, we must now find the sum. To find the sum, the formula is S of n is equal to n half multiplied with a sub 1 plus a sub n. Now we have all those terms, so all we have to do is substitute. Then becomes n over 2 times 1 times n. Now we just multiply the numerator and we get the answer. Mathematical induction has two steps. First, the base case, and second, the inductive step. The first step to the base case is to verify n equals 1. So we have 1 is equal to n times n plus 1 over 2. 1 is your first term, and now we sub n as 1. So at the end, you get 1 is equal to 1, which makes the statement true. To the inductive step. The second step is to assume that n equals k is true. So we have 1 plus 1, 2 plus 3 dot 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 plus n is equal to n multiplied by n plus 1 over 2, which is our S sub n, and we substitute n with k. So now we have 1 plus 2 plus 3 dot 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 plus k is equal to k times k plus 1 over 2. The third step is to prove that n is equal to k plus 1. So now you have 1 plus 2 plus 3 plus k plus 1, which is the next term after k, is equal to k plus 1 multiplied by k plus 1 over 2. All we did here was substitute k with k plus 1. As you can see, what we did in step B just results in k times k plus 1 over 2, so we substitute that. And now you turn that into a fraction form. When you reduce it, we get the same answer. Therefore, the statement holds true for n equals k plus 1. So now we have 4 plus 9 plus 14 plus 19 plus dot dot dot. We find the term again as we did the first example. A sub 1 here is now 4 and our d is 5. We substitute those in and we get a sub n is equal to f n minus 1. D is our difference and a sub 1 is our first. So now we find the sum. The formula for this is once again S sub n is equal to n over 2 multiplied by a sub 1 plus a sub n. Now because we have all those terms, all we have to do is substitute. So now we have S sub n is equal to n over 2 multiplied by 4 plus 5n minus 1. So you get n over 2 multiplied by 5n plus 3. You multiply that. First is the base case. We must first verify that n is equal to 1. So we have our first term, which is 4, is equal to n over 2 multiplied by 3 plus 5n, which is our S of n. You simplify that and you get 4 is equal to 4, which is true. Now let's move on to the second, which is the inductive step. So the second step is to assume that n is equal to k is true. So now you have 4 plus 9 plus 14 plus 19 dot 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 5k minus 1 is equal to k over 2 multiplied by 5k plus 3. All we did there, once again, is substitute n with k. This used to be 4 plus 9 plus 14 plus 19 plus dot 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 5n minus 1 equal to n over 2 multiplied by 5n plus 3, which is our s of n. So now we have to prove that n is equal to k plus 1. So now we prove that n equals k plus 1 is true. So we have 4 plus 9 plus 14 plus 19 plus 5k minus 1 plus 5 multiplied by k plus 1 minus 1 is equal to k plus 1 over 2 multiplied by 5 multiplied by k plus 1 plus 3. All we did there was substitute k with k plus 1. And as you can see, we can just substitute this whole thing with k over 2 multiplied by 5k plus 3. We continue on with 5k plus 1 minus 1 is equal to k plus 1 over 2 multiplied by 5k plus 5 plus 3. Now we multiply and we get 5k squared plus 3k over 2 plus 5k plus 5 minus 1. We also multiply this and we get 5k plus 8 multiplied by k plus 1 over 2. Now we put everything in one fraction and we get 5k squared plus 3k plus 2 multiplied by 5k plus 4 over 2. Plus 8 over 2, and on the other side we have 5k squared plus 13k plus 8 over 2. We add like terms and now we get 5k squared plus 13k plus 8 over 2, and the same on the other side. So now we have proved it. Therefore, the statement holds true for n equals k plus 1.
Thank you for watching!